Good day. This is Engineer Carmel S. Borlat, and our topic for Engineering Mechanics 2 is about the principle of work and energy. So at the end of the discussion, the students will be able to calculate the work of the force, the work of a force in a straight line, the work of the weight, and the work of a spring force. Then, lastly, the students will be able to apply the principle of work and energy to a particle or a system of particles. So, let's start with some application. A roller coaster make use of gravitational forces to assist the cars in reaching high speeds in the valleys of the track. So, from point A to point B, it is necessary that you calculate the summation of all forces at A is equal to summation of all forces at B, and consider the design of the height h and the radius of curvature rho to control the forces experienced by the passengers. So, in order to properly design the loop of this roller coaster, it is necessary to ensure that the cars here have enough energy to be able to make the loop without leaving the tracks. Also, another application is the crush barrels are often used along the roads. These are crush barrels. In front of barriers, this is the barrier for crush protection. So, in front of the barriers are the crush barrels. So, the barrels absorb the car's energy, the car's kinetic energy by deforming. So, if we know the velocity of the approaching car and the amount of energy that can be absorbed by each barrel, so we will be able to design the barrel itself, the cushion. So, work and energy. Did you remember the formula of our force? F is equals to ma. So it is important that you remember the this formula because it will be used in our topic today. So another equation for working kinetics problem involving particles can be derived by integrating the equation F is equals to ma with respect to displacement. So acceleration with respect to the displacement. So it becomes AT is equals to V dVds into F is equals to ma. So the result of the integrated formula will yield an equation that is known as the principle of work and energy. So if this is your particle and you applied force, then it has a component along its tangential and normal. Summation of forces along the tangential and summation of forces along the normal. So this principle is useful for solving problems that involve force. So if you experience solving problems involving force, velocity, and displacement, so this principle of work and energy is useful. It can also be used to explore the concept of power. So your reading assignment will be on power later on. So, continuation. A force does work on a particle when the particle undergoes a displacement. So, there is no work when there is no displacement along the line of action of the force. Again, a force does work on a particle when the particle undergoes a displacement along the line of action of the force. So, for example, a work is done as the product of force and displacement components acting on the same direction. So, if you have force F applied on this particle here, then there is work done and the particle moves from S1 to S2. So, your work is in this direction. So the work is, so if the single angle of the force and displacement vector is, if the angle between the force and displacement vector is theta, this one, the increment of work du, so work is represented by u, done by the force is du is equals to f ds cosine theta. So the work done here is due to the force f cosine theta because the particle is moving from S1 to S2. So there is work done by f cosine theta. By using the definition of a dot product and integrating, the total work can be written as, so the work done from point 1 to point 2 is the integral of f dot product of dr, where from R1 to R2. And if ever f is in the function of position in terms of ds, which is commonly applied and used in kinetics, then the work done from 1 to 2 is equal to the integral of f cosine theta ds and from S1 to S2. And if it is a straight line, it is much easier to remember. You have work done from 1 to 2, from here to point 2, is equal to the force applied, cosine theta, from S1 minus S2. So remember this formula, it is very useful in solving problems. So work is positive. Remember, work is positive if the force and the movement are in the same direction. If they are opposing, then the work is negative. If force and displacement directions are perpendicular, the work is 0. So there is no work when the force is, the direction of the force is perpendicular to the displacement. Again, the work is positive if the force and the movement are in the same direction. The work is negative when the force is opposite to the direction of the displacement. And there is no work done if the displacement, if the force applied is perpendicular to the displacement. So as a review, what's the work done by the force F? As you can see, from point 1 to point 2, the force applied is perpendicular to the movement, to the displacement of the particle. So what is the answer? Is there a work done by force F to that particle? Yes. No, the correct answer is 0. There is no work done by the force F from point 1 to point 2 because it is perpendicular. Second, if a particle is moved from point 1 to point 2, the force done on the particle by force Fr will be, among these choices, what is the correct answer? Is it A or B? Remember that the movement is from here to here. And the direction of the force is, you can resolve the force into the tangential and the normal. So, but we know that there is no work done by forces perpendicular to the movement of the particle. So there is only tangential force. So our answer will be A or B. But which is the correct answer between A and B? Also remember that the direction of the force is towards 2. and the movement is from 1 to 2. So therefore, it is positive. The correct answer is A. Summation of tangential forces ds, integral of the summation of tangential forces ds from S1 to S2. And it is positive because the displacement is the same direction with the force, Ft. So the second work of a weight, second topic for today. The work done by the gravitational force acting on the particle or the weight of an object can be calculated using this equation. So from point 1 to point 2. And this is your particle with its weight, the force of its weight downwards. So the work done from point 1 to point 2 is equals to the integral of the negative w dy from y1 to y2. So when it is constant, then we have the formula for work from 1 to 2 is equals to the negative of weight multiplied by y2 minus y1, or the delta y. The change from this point up to this point in the y-axis, na vertical. So take note that the work done by the weight is negative. Negative the work done by the weight multiplied by delta y. So the work of the weight is the product of the magnitude of the particle's weight and its vertical displacement. Vertical displacement, delta y. If delta y is upward, the work is negative, since the weight force is always down. Third, the work of a spring force. When stretched, I want you to imagine a spring, an unstretched position of the spring. So, when you stretch it, imagine is stretched, the linear elastic spring develops a force of magnitude Fs, and that Fs is equals to Ks, and K is your spring stiffness and S is the displacement from the unstretched position. So, the work done by the spring force moving from position 1 to position 2 is equal to this equation. So, to simplify, work done of spring force from position 1 to position 2 is equal to 0.5 K S sub 2 squared minus 0.5 K S sub 1 squared. If a particle is attached to a spring, the force Fs exerted on the particle is opposite to that of the spring. Thus, the work done on the spring by the spring force, the work done on the particle, by the spring force will be negative. So, if this is the work done by the spring, if this is the work done by the spring force, then this is the work done on the particle. And it is opposite to the the Fs exerted on the particle is opposite to that of the exerted spring. So that is why it is negative. So it is important to note the following about spring forces. So the equation above are for linear springs only. Recall that a linear spring develops a force according to F is equals to Ks. And the work of a spring is not just spring force times distance at some point. So then always double check the sign of the spring work after calculating it. It is positive work if the force of the object by the spring and the movement are in the same direction.